So here we're taking a look at the physics exam 1, question 1. This is the first question outside of the multiple choice, and it looks like this is going to be on an earlier chapter. Um, let's see, it's the law here. Pull it up. It's chapter 21. I don't think it says what the law is, but it's the KQR. Yes, KQ1, Q2 over R. So it says three spiders are resting on the verticals of a triangular web. The sides of the spider web have a length of A, as depicted in the figure. Two spiders, S1 and S3, have plus 7 microcoulombs. And the other spider, S2, has a charge of negative 7 microcoulombs. It's asking us what's the magnitude and direction of the net force on the third spider, spider 3. Okay, so that's the guy all the way out there. And then the spider moving to the origin, and then I'm assuming okay, and then it's just asking. So this one is not going to be like finding the minimum, because that was a similar question in the homework, which I really should brush up on. Yeah, so let's write what we know. We know S1 equals, S2 equals, and S3 equals. We also know the formula we're going to need is F12 equals K, absolute value Q1 Q2 over R squared. Okay, that's what we need here. And the next thing we should do is, well, what's R? R is going to be the distance right here, which if we have a side of A over 2 here, and the other one's length A, then we can write the length here, R, as the square root of A squared plus A, well, we can do A squared over 4. So that's going to be the length for both of these. So now we have our R, we have Q1, we have Q2. I think we can just plug it in now. So we're going to have an F23 and an F13. F13 and F23. So F13 is going to be equal to, and then F23 is going to be equal to, and this is going to be 8.99 times 10 to the 9th. And this is going to be, let's see, the square root of A is 0.48. Square 0.48 squared plus 0.48 squared over 4. And at the top, we're going to have Q1 and Q2, which is going to be 7.8 times 10 to the negative. Ooh. Let's see, what is micro? Micro is going to be equal to times 10 to the negative 6. So let's write these down. This is going to be 7.8 times 10 to the 6th. This is going to be negative 7.8 times 10 to the negative 6. This is going to be 7.8 times 10 to the negative 6. So let's multiply this 7.8 times 10 to the negative 6, and this should give us f13. And 8.99 times 10 to the 9th all over. This is going to be the square root of 0.48 squared plus 0.48 squared over 4, and this is going to be 7.8 times 10 to the negative 6 times 7.8 times 10 to the negative 6. It looks like these will be the same charge. Let's plug this into the calculator. Hold on, I forgot to hit something. All gonna be multiplied by 999 times 10 to the 9th. 7.8, 7.8, 8 squared, 4 squared over 4. That should work. I'm wondering what's going wrong here. That's the same. And a squared plus a squared is 5/4 a squared. So we could, oh, I get it. Because it's r squared, and we have something in the square root, we just remove the square root. Okay. This is actually this squared. So f13 equals f23 equals 1.899, and this would be newtons? Yes. So from here, we have, let's see, we have an angle. Yes. They want to know the magnitude and the direction of the net force. So we find this angle here, right? Now, what is that angle there? Well, that's the tan inverse of opposite over adjacent. Or we could keep this, change this, flip it. Nah, let's not. Best not overcomplicate this. Let's just the inverse tan of this. It's going to be 0.48 over 2 over 0.48. And I'm getting 26.56 degrees. Yes, 26.56. So now, what do? Well, we say that f13 is going to equal 1.899 times cosine theta I hat minus sine theta j hat. And then we are going to say the same thing, that f23 equals 1.899. This is going to be cosine theta I hat plus sine theta j hat. Or no, actually this would be double positive, this would be double negative. From here, this would be down, and this would be repelled. So there's actually going to be double negative here. It's both going downward and to the left. The other one was going to the right, but also going downward. So then these are going to equal. Well, it should be pretty close. I'm getting 1.698 I hat, and this is going to be minus 0.849 j hat, and then this one's going to be negative 1.698 I hat minus 0.849 j hat. Okay, I think that would be the answer to part A. The net force, actually, hold on, not quite. The net force, F net equals F13 plus F23, which equals, well, let's see, those cancel out, and these would become 0.0 or 0.849 times 2, which is 1.698 j hat. So that would be 1.7 newtons, and the angle is 26.56 degrees. They don't want the angle, they want the direction. So actually, because this is, I'm so stupid, because this is directly a j hat, directly downward, this would be 90, 180 to get to here, and then 270. And then actually the direction here would be, where do they want it from the origin, right? No, they just want the direction there. Okay. 270 should be 360 minus 90. Yeah, it should just be straight down. That's part A. And part B, it asks, suppose that spider 3 is moved to the origin now. Would the net force on the spider be greater, less than, or equal to? Well, I don't think we need any math here. We're pushing it closer to things that are trying to, or the forces that are attracting or repelling it. So for B, greater, I'm going to say this is A. And then C, this actually might require some calculations. So let me have a little button here, probably clears this real quick. Yeah, okay. So now for C, the magnitude and the direction of the force while it's resting on the origin. Well, F13 is going to equal 8.99 times 10 to the 9th And the r squared here is just going to be a over 2. So it would be a over 2 squared, and this is going to be 7.8 times 10 to the negative 6 squared on top. And then same thing, f23 is going to equal 8.99 times 10 to the 9th all over a over 2 squared. 7.8 times 10 to the negative 6 squared. So f13 equals f23 equals 8.99 times 10 to the 9th times, see, 7.8 times 10 to the negative 6. Let me square the top. It's going to be over 0.48 over 2 squared. Getting 9.4 should be. Yeah, it should be. Can we double that? Yeah. This is 9.49. So then it's asking net force. So for C, F net equals F13 plus F23, which equals 18.99 newtons. And this is just going to be just straight up and down. So then the direction here would be positive, would be repelled in it. So it would just be 270. So there you go. That's how you do part A, part B, and part C for the first question in the physics physics exam 1. Okay.